Okay, this is the first in several videos on solving systems of equations. Systems of equations, quite straightforward. Uh, Generally what we'll be looking at are linear equations, although we may have some higher degree at times as well. And what we have, we'll just give a quick example here, we are looking for the set of xy values, and with a linear equation that'll be three choices. We will either have an empty set, meaning they're parallel, there's no solution. We will have one answer, or we will have an infinite set. Okay, so one answer are essentially lines that intersect obliquely, and infinite, obviously we would have the same lines running one on top of the other. So there are an infinite number of solutions. So we're looking for that special set of xy values to tell us what's going on here, to tell us where these intersect. And we can tell by the solutions we get what the graphical piece is. Now there's four ways to do this. Two of them are primarily technological, the first being graphing. Again, use your calculator to do this unless you're willing to sit down with graph paper and a ruler and really be explicit about your graph. Most of the answers here will come out to be pretty readable, understandable answers. They'll come out at nice fractions, halves, thirds, integer values, but not all of them will. So the other option you have there is to turn this into a matrix, and again you can use your calculator to do that. I'm talking TI-83, 84, but I know there are other models of calculators out there that will do this. And then the last two methods, which we're going to talk about today, are by substitution and by elimination. So we'll start by identifying our equations as A and B, and we're going to start with substitution being our first method. And substitution just says what we're going to do is we're going to pick one of these equations and we're going to solve for one of the variables, and then we're going to take that value, plug it into the other equation, solve it, because then we'll just have an equation of one variable that will give me a value which I can then substitute back in. So it's really pretty straightforward. So for example here, I'm going to start with example B, or I'm sorry, equation B, and divide everything by a -2, so that I end up with -5/2 plus 1/2 x. So now I have this value of y that I can put back in for y in this equation. Okay, that's what we're going to do. So I'm going to take equation A, and I'm going to say 3x plus 4 times -5/2 plus 1/2 x is equal to 5. Okay. Now if I expand this, I will get 3x plus a, what would this be, a -10, because the 4 and the 2 divides out, leaves me with 2 times -5. Here the 4 divides out with 2, just gives me 2, so I'll have plus 2x equals 5. Bring my terms together, I get 5x minus 10 equals 5, so that 5x equals 15, and that means x is equal to 3. So now I have a value of x, and what I can do is put this back in either equation to find out the value of y. My recommendation, go ahead and put it in both to make sure you come out with the same value of y. This is just a nice confirmation that you have come up with the correct answer. So for the first equation, okay, we're going to move our thinking up here now. I will have equation A, so I'm going to go 3 times 3 plus 4y is equal to 5, so that will be 9 plus 4y equals 5. 4y equals a -4, so y must be equal to -1 according to the first equation. If I plug that same value of 3 into equation B, I will get -2y equals 5 minus 3, because 3 was my substitution, So negative 2y is equal to a positive 2. Divide both sides by negative 2, and I get y equals negative 1 again. So by substitution, I'm showing that my solution is just the single point 3, negative 1. Now, the second way I could do this is with a process called elimination. Generally, elimination is kind of my go-to default because it's so related to matrices and linear algebra. And I think in the long run it's just an easier way to think rather than have to do all the substitution. So I'm starting with my two equations, 3x plus 4y equals 5 and negative 2y equals 5 minus x. Now in order to do elimination, essentially what I need are the same variables on the same side, constants on the other side, and then I need one of the coefficients of one of my variables to be opposite. So let's go ahead and just get our equations to work, right? Again, here's A and here's B. So I'm going to rewrite B, and I'm going to write it alongside A. So I'm going to have 3x plus 4y equals 5. I'm going to have x minus 2y equals 5. And now I want to get rid of one of these variables, either x or y. And right now it looks like if I multiply equation B times a 2, then I would have a 4y and a negative 4y, which is what I'm looking for. Same variable, opposite coefficients. So I'm going to go a little horizontal here. 3x plus 4y is equal to 5. And if I multiply that second equation by 2, I will get 2x minus 4y equals 10. Now, the process of elimination says now that I have these opposite coefficients, here, what I'm going to do is I'm going to add these two equations. And this just works on the principle that equals added to equals are equals. And you've been doing this for a long time with any sort of arithmetic or algebra or things like that. For example, if I take 2 is equal to 2 and I add 1 to both sides, well, here we'll do it this way. If I add these two equations, I will get 3 equals 3. Equals added to equals are equals. So that's what I'm going to do with this equation right here. I'm just going to add them together. So I will get negative 4y plus 4y is 0, so I don't even have to write that. 3x plus 2x is equal to 5x. I have 5x equals 15. Lo and behold, x is equal to 3 again. So notice the elimination method is just that. I get these coefficients, so they're opposites, so I can add the equations together. That will eliminate one variable, and then it makes my solving pretty easy. And then again, I would go back and I would substitute this value of x equals 3, okay, and I'm going to go back and I'm going to substitute it into both of these to make sure that I get the same value of y. And of course I see, I got x equals 3, I'm going to get y equals negative 1 again. So we don't need to do that here. But again, once you find one numeric value, substitute it back into both your original equations so that you can double check your work and make sure you're on the right track. Okay, so I think that takes care of our basic introduction to the idea of solving multiple equations, systems of equations, with the two basic algebraic methods. In the next lecture or two, we'll do some examples of problems that actually make some story problem application of this.